Okay, so my goal in this video today is to introduce you to the topics of Lab 9. So this should just kind of be thinking about what I would typically do before we start lab at the very beginning of lab. So the first thing I want to talk about is just some general overview basics here. And I have drawn here, I started this already because I just messed up, so I'm not going to rewrite everything. But in your kit, you have 3 different lenses. You have 2 what's called converging lenses. We call these converging lenses, or we can call them convex lenses. We're going to call them A and B. A will be the one, we're going to call A the fatter one. So one of these is quite a bit fatter, and one of these is quite a bit skinnier. When you're handling the lenses, try to be careful not to get your fingerprints on them because finger oils over time will damage the lenses and leave like black marks on them, and it gets pretty gross. So use kind of tissues or Kleenexes to handle these lenses and stick them in a lens holder and then mount them on the meter stick in whatever way works for you. So we have 2 converging lenses. You also have a third lens, which is a diverging lens. It's also another word for diverging lens is concave. Concave is a mnemonic that helps me remember that concave lenses always cave in the middle. We are not going to use this lens this week. We will wait to use that lens next week. So in activity 1.1, we are going to be measuring the focal length of these 2 lenses. And we'll be measuring the focal length of these 2 lenses by taking rays of light that are kind of traveling from the left and entering this lens. And when rays of light that enter parallel travel through if you imagine kind of the center of this lens, they will meet, and every single one of those rays of light will bend through this one spot here, and this one spot is the focal point. Where this distance here from the center of the lens to the focal point is the focal length. Uh-oh, need to open something back up. We'll get it back up in a second. Hopefully. Oof. Okay. So we're going to try and get rays of light to be parallel. And how do we get rays of light to be parallel? They're not normally parallel. So to do this, I want to show you a PhET simulation. It is a great PhET simulation if you want to get a good intuitive feel for how rays of light work and how ray diagrams work. This one right here. So what I have is a light. And if I put this light source really close to my lens, you can see that these rays of light are most certainly not entering the lens parallel. Let me move this out of here. You can kind of see, right? These rays of light are spreading out the farther they get away from the light source. And this light source I should call object. So the farther they get away from the object, which is the source of light, the more spread out they are. So when this light is really close to the lens, they're still spreading out. And actually you can see the way that these things pass, this yellow X here is actually the focal length of this lens. They most certainly don't actually all cross at the focal length of the lens. But the farther away this light source gets, let me move it all the way out to here. Now if we look right here at the lens, these 2 rays of light, as they enter the lens, do you believe me that they are almost entering the lens parallel to the lens? And actually, if you see these 2 rays of light, they entered the lens almost parallel to the lens. And when they cross, they actually almost cross right on this yellow X, which is the focal length of the lens. So in activity 1.1, you're going to be focusing light not from an object that's really close to the lens, but from an object that's really far away from the lens. So in the intro video that I used, I focused light from outside my window. So I looked at a tree that was across the street and tried to get an in-focus image of that tree. And you're going to have a little cardstock sheet of paper that you're going to be moving back and forth. And if you put your cardstock right at just the right location, then you'll see an in-focus image of whatever it is that's outside your window or whatever it is that you're focusing. Okay, so that's what we're doing in activity 1-1. And now let's move back to this and move on to talk about activity 1-2, which is that most of the time we actually don't have rays that are incoming parallel like this. So using this kind of special setup here, we're going to be able to measure the focal point of the lens, and that's going to be useful to us because now we have the focal length of our two lenses, and we can go on to do other experiments. So in activity 1-2, we are going to put the light source close. So if I put my light source closer, let's just kind of move things a little more like this. If I put the light source close, you can see that they spread out, and while they don't all converge and cross right at the yellow X where the focal point of the lens is, they do all cross at a spot, okay? And if I have a screen and I'm moving this screen back and forth, there will be a location where I can put my screen or my little piece of cardstock that I've supplied you with and find an in-focus image of something. So in this investigation, the object, which is this little light source over here, is actually going to be a piece of cardstock with screen mounted into it. And we are going to visualize the rays that exit that piece of cardstock and bend and form an in-focus image of the screen right back here. So there's some rules for drawing how we do this. And instead of drawing all of these rays, we pick what's called principal rays. We're going to draw a principal ray diagram like this. And I actually don't want to put a screen here. I want to put an object over here on one side and an image over here on the other side. And actually I had this all set up to work for that one, but we're going to make this be a little bit better. Okay, so over here is the object, and this will be what like a screen door kind of mesh grid over here. And then on the other side, you have a piece of cardstock that you're going to find an in-focus image of the shape of the mesh screen over here. So we draw what's called principal rays. So there's 3 rays that we are going to draw. Rather than drawing all of them, we just pick 3 of them. So the first ray that we draw enters into the lens parallel to this blue line right here. So this blue line right here we call the principal axis of the lens. So the rays enter the lens parallel to the principal axis. And we already know what rays that enter a lens parallel do, right? They bend and they go out through the focal point. The second ray that we're going to draw is actually going to be like the opposite of this one right here. Rather than coming in parallel and out through F, the second ray we're going to draw is this bottom one here, which is in through the focal point of the lens, and it bends and goes out parallel. And the third ray that we're going to draw goes straight in through the center of the lens, so right where this principal axis intersects the center of the lens, and it bends, and it doesn't bend, and it just goes in a straight line. And where these 3 lines all meet will be the location of an in-focus image. So drawing a ray diagram like this takes a little bit of getting used to, so I wanted to step you through a ray diagram for the first time here. So I'm going to draw a ray diagram. So I'm going to draw the principal axis of my lens right here, and I'm going to put some markings here. This is an inch ruler that I am using, so I'm putting a mark every 1/2 inch. It doesn't really matter, like that. And then let's go ahead and put our lens right here. And I'm going to draw my lens looking concave, but I'm going to measure everything according to this line that goes straight through the center of the lens. And let's just say I have, this isn't actually what we'll be doing in activity 1-2, but just to give you an example, let's say I have a lens with a focal length is 15 centimeters. And an object, CO, an object that is 50 centimeters away. Okay, so if this is my meter stick, let's just say that each one of these marks is 10 centimeters. So one mark is 10 centimeters. So if I move 10 centimeters away from the middle, then that's 10 centimeters, which means that F must be here. Because that's, right, if I'm going 10, 20, F will be halfway between there. And I'll put a focal point on both sides of the lens. So there's going to be another F right here. The object distance is the distance from the center of the lens to the location of the object. So let's count. We'll go 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters, 50 centimeters. So I'm going to draw an object that is an arrow here. Arrow is kind of the conventional thing to draw, but actually what my object looks like was a triangular shaped mesh grid. Yours will be some sort of mesh grid. It might not be triangular shaped. I made a bunch of different shapes when I was putting these things together. But I'm going to stick with an arrow here because that's what we conventionally draw. But what we're looking for is we're going to be moving the screen around until we see an in-focus image of this. Okay, so let's follow those rules of a principal ray diagram. So I'm going to draw my first one, which is a ray that exits the object and comes in to the lens parallel to the principal axis of the lens. And that ray is going to bend and go out through the focal point of the lens. So here's what my ray does. It leaves the object, it travels and bends to the lens, and it goes out through F. The second ray is the one that comes in through F. So I'm going to line this up like this, draw a ray that starts at the tip of the object and travels through the focal point on its way to the center of the lens. And then it's going to bend and go out parallel to the principal axis of the lens. And this should be the location of an in-focus image right here. So I'm going to go ahead and just kind of pencil that in. But it turns out, unfortunately, that two lines will always cross. So if you want to be certain that your ray diagram is correct, you need 3 lines that all cross together. So we'll get the third line in here. It'll start at the tip of the object and travel in a straight line without ever bending. And there you go. And I did much better than I normally do, and probably much better than many of you will do. A lot of times these rays cross and they're sort of like, I don't know, like that. They'll make a little triangle and you're sort of like, well, they kind of cross somewhere around in here. That's totally fine. When you draw your ray diagram, I don't need them all to cross exactly in a dot. What I do want is to have your 3 incoming rays follow these rules, the 3 incoming rays like this. And you have to do this on test 4 coming up anyway, so this is good practice for getting started doing these things. All right, so I had, my object distance was 50 centimeters. So there was 50 centimeters. And my image distance was 10, 20, I don't know, we'll call it 12. Or sorry, not 12, 22. So 10, 22 or so. And I'm just sort of guessing, right? I know it's not quite 25 because that would be here. So 22 or 23 is about what I thought. So if I had a lens with a focal length of 15 centimeters, and I had this mesh grid that was placed 50 centimeters from the lens, then I would expect to observe an in-focus image right here. somewhere between 20 and 25 centimeters away. And now the trick is that in the lab, you get to go and actually set this up and observe if you do actually observe an in focus image at that spot. And so your lenses actually, neither of your lenses have a focal length of 15 centimeters. They are both different than that. But one is less than that and one is larger than that. So that's about what that is going to be. And that's what you're doing. And I expect you to draw a principal ray diagram for the first time here. And you're doing something like that in your pre-lab as well. Let's see if there's anything else I wanted to do. I think that is probably it. Just a couple of quick tips on this. I want you to probably work. You'll save yourself some effort if you can find a way to set this up in a place that you can keep it, especially your meter sticks. So you're going to kind of cut apart a piece of paper and tape together to make a meter stick. And if you can mount that in a place where you can keep it for the next week, that will help you. So then you won't have to set that up again next week. If not, it doesn't take too long to just take it up and put it back down. A second tip is you need to be able to move the meter stick around. So either set it up so that the zero end of the meter stick is looking out at a window, or set it up in a way that you can maneuver things around a little bit, because you need to be able to kind of focus light that's coming in from the window in that first activity. A third tip is do this experiment with the lights off. So in activity 1-1, you want to have like a window open so that you can focus the light. In activity 1-2, you want to make sure that the lights are off in the room, and the darker the room is, the better it will work, because you like to be able to see the location of the in focus image, right? If your light bulb isn't all that bright, then it might be pretty dim. And I think that is it. So good luck and have fun, and let me know how it goes.